this one clear? The integral of 5 over x dx, 5 natural log x plus a constant c. Is this okay? Okay, so problem 3. Shauna, I'm happy you did well. Okay, so we just started. Let me know if you want to work on this problem. We're going over the test, only the problems we need to. And then we'll go back to test 2 and test 1. Do you need help with this one? No. This one is right here. We just looked at it. This is a function that we have to remember. The integral of 1 over x is natural log of the absolute value of x. The derivative of natural log of x is 1 over x. Okay. Good. Again, do we need to work on number 3? Anybody? Okay, do we need to work on number 4? This was the extra credit. So if you did it correctly, I added 9 points to your test grade. Okay, number 5. Do we need to work on number 5?
Can we do this one?
Yes. So here we have the marginal cost, which is c prime of x equals x to 5/6. And they want us to find the total cost of installing the first 60 and then the extra 12. So the first 60 and then from 60 to 72. And if you remember, I said you can use the graphing calculator because I don't want you to spend time on arithmetic. So the first one is the total cost between the so for the definite integral from 0 to 60 from x to 5/6 dx. And yes, you can, solve it, but get the number with a graphing calculator. 5/6 plus 1 is 11/6 divided by 11/6 from 0 to 60. And then you just put it in the graphing calculator to get the number. And if it said they wanted an exact, but you found an approximation, I consider it okay. So then we have to flip the 6 over 11. So this is 6 over 11, x to 11 over 6 from 0 to 60. And then you can approximate it with the graphing calculator. Is this okay, or do I need to put it in the calculator? Okay, the other total cost is between 60 and 72. So total cost number 2. This is between 60 and 72 of the same thing, x to 5/6 dx. And you can jump here already. It's 6 over 11 times x to 11 over 6, but this time from 60 to 72. And you approximate it with the graphing calculator. Again, do I need to go determine these numbers? Okay. Let's take a look at number 6. Do we need to work on number 6? This is the sum of two integrals, from -4 to 2 from the first one, plus from 2 to 4 from the second one. Is this a yes? Do I have to show anything in number 6? Okay, number 7. Find the area of the region bounded by the graphs of the given equations.
Can we do this one?
Yes. So here we have y equals 5x plus 6, and we have y equals x squared. And we have to find the area. We have to find the point of intersection, meaning we have to set the two y's equal to each other. X squared equals 5x plus 6 means x squared minus 5x minus 6 equals 0. If you don't remember how to factor, you just use the poly feature, which is okay. But factoring on this polynomial is very easy because it's x minus 6 and x plus 1. So you have x equals -1 and x equals 6. So when you graph, you will graph x squared, which is a very nice function, y equals x squared. And then remember, the intersection is when x equals -1, so at this x, and at x equals 6. So my units are not good, so I'm just gonna 1, 2, 3, 4, 5, 6. So when I graph, it's gonna be something like this. So y equals 5x plus 6 when x is 0, y is 6, 1, 2, 3, 4, 5, 6. So 0, 6. And when y is 0, x is -6/5. So it's right here. So that's why when I graph, let me use a different color for the line. So this is a line y equals 5x plus 6. And now I have to extend the graph of the y-axis. So that's how I get this area. So then the area is the integral from -1 to 6 from above minus below. And yes, you can put it in the graphing calculator. Is this okay? Any questions? Okay. Number 8. Evaluate. Be sure to check by differentiating before you enter it. Sure. Why not? Is that a yes or a no?
We can do this one.
Very good. So here we have the integral from e to 7x plus 9 dx. Remember, we have to use a substitution. That's the safest thing to do. So y equals 7x plus 9 and dy equals 7 dx. So we need to fabricate, so to speak, a 7. Because 7 and dx will equal dy. So this and this will be the dy. And this is very simple. Now it will be e to y. So then we have 1/7 e to y dy, which is e to y over 7 plus a constant c. But yes, I have to go back to the substitution. So it's e to 7x plus 9 over 7 plus a constant c. Is this okay? Okay. Number 9. Yes, somehow this gave or created issues, and I don't know why. Because we did like 3 or 4 identical here. So the integral from 0 to the square root of 19, and second of all, it's a definite integral. You can simply plug it in the graphing calculator. You didn't really need to do anything if you didn't want to. So we do have to use y equals 8 plus x squared. We do have dy, which is 2x dx. One option is to split the 6 and not write 2 and 1/2. Just split the 6 into 2 and 3. So then the 2 with the x and with the x. 2x and dx. Oh, sorry. One more time. So y equals 8 minus x squared. dy equals 2x dx. As I showed you, you can multiply by 2 and divide by 2. But there is no need because I have a 6. So I can split it into 2 and 3. Or just put 1/2 and 2. It's fine. You're going to get the same answer. So, but now this, and this are in dy. So therefore, I have the integral from, I can put the 3 outside. Again, 2x and dx will be dy, and this is y to 1/3. It will be a terrible mistake to copy the same limits of integration. That's not possible. Because these limits are for x, these are not limits for y. So I have right here when x is 0, y is 8, and when y is the square root of 19, which means squared will be 19, 19 plus 8 is 27. We must change the limits of integration. So then we have 3. I increase the power by 1, so I get y to 4/3. I divide by the same thing, and I go from 8 to 27. I flip, I get 9/4. When I plug in 27, I will apply the cube root first. So this is 3 to the 4th, which is 81, minus. I take the cube root of 8 first, so it's 2 to the 4th, which is 16. So I have 9 times 56, 50, what am I doing? 65. 65 divided by 4. So what do I get? You can plug it in the graphing calculator from the very beginning and get the number because it's a definite integral. However, you cannot do this with an indefinite integral. And the next one is an indefinite integral. But it's the same thing. But tell me if you need help with this one or we need to work on it.
Can we go over number 2?
Yeah. So here we have the integral from x, the square root of 5 minus x squared dx. All steps are the same, except that this is an indefinite. So we have y equals 5 minus x squared, and dy equals negative 2x dx. So I need to multiply by negative 2 and divide by negative 2. Because I need a negative 2. That's no big deal. I can always make up a constant. I can never make up an x or a square root of x or anything with x. A constant, a factor, yes, always. Gladly. So then I have negative 1/2 in front. The integral from, again, the negative 2, the x, and the dx are in dy. And this is y to 1/2. So negative 1/2 We add 1 to 1/2, which is 3/2, y to 3/2, over 3/2, plus a constant c. I increase the power by 1, I got 3/2, and I have to divide by the same number. And now I flip to 2/3, and I simplify, and I get negative 1/3. You can write it whichever method you want to use. 5 minus x squared to 3/2 plus a constant c. Because it's a indefinite integral, we have to go back to the variable that was given. Now, demand and supply, somebody got a supply that was a surplus, the producer, I think it was, which was negative. They will never sell us something so that they are in minus. That's never going to happen. Right? So you can never get a negative number. And also remember, it's an area, and it's enclosed. It's not between the x-axis and such. So it can never be negative. So let's see if we need help with this one. We did this problem last time. Do we need to look at it?
Yeah.
Okay, very good. So let's take a look. So we have the demand x minus 8 squared, and the supply x squared plus 6x plus 20. So we have to set them equal to each other. X squared minus 16x plus 64 equals x squared plus 6x plus 20. I subtract and I get negative 22x, and then I move this and I get negative 44. So then x is 2. When I plug in 2 minus 8 is negative 6, negative 6 squared is 36. So the equilibrium point is 236. So the consumer surplus will be the integral from 0 to 2 from x squared minus 16x plus 64 dx minus this area, which is 72. The producer surplus is 72 minus the integral from 0 to 2, but from the other function, x squared minus 6 plus 6x plus 20 dx. Oh, I'm so sorry. Sorry. So I had x minus 8 everything squared had to be set equal to s of x. And I squared this, I got 3 terms. I set it equal to this. I simplified x squared. I moved 6x. I got negative 22x. I moved 64. Negative 64 plus 20 is negative 44. Then I divided by negative 22 and I got 2. I plug in 2 here. 2 minus 8 is negative 6. Negative 6 squared is 36. So this is the equilibrium point. So the consumer surplus is the integral from 0 to 2 from this function minus this product, 72. And the producer surplus is this product minus the integral from 0 to 2 from the other function. So when you plug this in the graphing calculator, maybe you didn't plug it in correctly, who knows? So we have the integral from 0 to 2 and this is x squared minus 16x plus 20, of course dx, and minus 72. And this cannot be a negative number. Oh, can it be the consumer surplus Oh, in our case, it can be. Yes, for us it can be. But for them, it cannot be. Sorry. 72 minus the integral from 0 to 2 from x squared plus 6x plus 20. X squared. No, that's not what I meant. X squared plus 6x plus 20. For them, for the producer. For the producer, it will never be negative. They will never sell us anything if they're in minus. Okay? Find the general solution and the particular solution of the given initial the particular solution for the given initial condition. So this is a differential equation. Do we need to look at 12?